Max of both of these, 3 and 6 will be our answer. But no, this is totally wrong. So hello everyone. Today we are going to discuss this problem, length of longest subarray with at most k frequency. This is the third question of today's biweekly contest. So let's see the problem first. So you are given an integer array nums and an integer k. The frequency of an element x is the number of time it occurs in an array. Let's say if this x number is equal to 1, let's say we have been told that x is equal to 1, then the frequency of this element x is referred to as the number of time this number 1 has encountered in the array. So after that they have told us that an array is called good if the frequency of each element in this array is less than or equal to k. And a particular array is called as good if frequency of all the elements, let's say frequency of all the elements, let's say x is some element in that array, so frequency of all the elements in that particular array, if it is lesser than equal to k, then that array is referred as a good array. Now what we have to do is we have to return the length of the longest good subarray of nums, and subarray is a contiguous non-empty sequence of elements within an array. Okay, cool. So what they are trying to tell us is that we have to return a subarray with the longest length. First thing, that we have to return the subarray with longest length, and it should follow one condition. And what is that condition? The condition is that each and every element, that is each and every element in that subarray must have their frequency lesser than or equal to that given number k. So you have to find this subarray with longest length satisfying this condition. So that was the question. And now let us try to look at the example, and we will try to form some logic. So the first example that is given to us is 1 2 3 1 2 3 1 2, and the value of k is given as 2. Start with this first number, that is 1, and let us keep one map, and in this map we'll be storing the frequency of these numbers, right? So we'll be starting from the start of the array, that is the 0th index, and we will see that what is the frequency of 1 over here. So currently in the map the number 1 does not exist, so we can say that the frequency of number 1 currently is equal to 0, and at max we can accommodate 2. We'll simply take it and we'll increment the frequency of that particular number, then we will move ahead. So now we are on number 2. So again let's see, the frequency number 2 is 0, it is not present currently, so we will add that number, we will increment its frequency. Again we will move forward, again we will say that for 3 again same thing, it is not present, so we will just put it and increment its frequency. Now as we move ahead we again encounter 1 once again, and we already have 1 stored in our map with frequency 1, but even if we take this one, our frequency will become 2, and which is lesser than or equal to 2, we can say that condition is still satisfying, so we can take this one. And as we want the longest length, we can go as far as we can. So after that we will take this one, we will increment the frequency of 1 with 2, then we will move forward. Again, yes, 2 is again present but with frequency 1, but we can accommodate one more 2 over here. So yes, we will take this 2 also in our subarray, and we will just increment the frequency with 2. Again we will move forward, we will encounter 3. 3 is also present, but still we have capacity to accommodate, so we will increment its frequency and we will take this 3 into our subarray. But as soon as we will reach at this index, we will see that again we are encountering 1, but already the frequency of 1 is 2, and we can only accommodate as per the condition. We can, in our subarray, the subarray is called as a good subarray if the frequency is lesser than or equal to k. So currently our k is given as 2 and the frequency of 1 is already 2, and if we try to accommodate this in our current subarray, then the frequency will become 3 and our condition will not satisfy. So definitely we can't take this one, we have to end our subarray over here. So we will calculate this length. So we can find that this length is equal to 6. and hence the max answer is 6. If you try to make any subarray starting from over here or any of this part, you won't be able to find any subarray with length greater than 6, and hence this will become our answer. But let's try to take one another example, and from this example it will be very clear to you that how we have to proceed. So that example is 1 2 2 again 2, then 1 3 4 5 6. Cool. And value of k is given to us as 2. So now again, as I have told you about this kind of logic, that we will store the frequency in map and we will keep on going ahead as far as our conditions are satisfied, and once our condition is not satisfied, we will break that subarray over there and we will start some new subarray. That is the logic that I was telling you right now with the first example, that you can form from the first example also. But now let's try to implement that same logic over here, and you will face some error with this logic. And what is that error and how we are going to then make the perfect logic, that we will try to see. So again, over here also we will start. Currently there is no 1, so we'll add 1 to our map with frequency 1. Then we encountered 2, so we added frequency of 2 as 1 also. Again similar thing, increment the frequency as far as we can take. Now again at this point when we encountered 2, you can already see that the frequency of 2 is equal to 2. If I try to accommodate this 2 into my current subarray, then the frequency of 2 will become 3, which will contradict to whatever condition they have given to us, that our frequency should be lesser than equal to k. So I can't take it. So I have to break this subarray over here. So let us break this subarray over here as per the previous logic. And current length of the subarray is 3. Okay, so remember this thing. We have broke our subarray over here, and since we can't accommodate this two, so we have break our subarray over here and we will be starting a new subarray from this index. As we break our subarray and we are making a new subarray, then obviously we have to erase our whole map also. Means now the frequency of 1 2 3 4 everything is reset back to 0. Correct? So now when we start from over here again, we are making a new subarray. So there is no 2 right now, because we have erased the map once we break our subarray and when we are making a new subarray. So currently there is no 2 present in our map. So we will add that 1 2 over here as we have the capacity to accommodate it. Then again we will go to 1. We can add 1 over here since it is of only one frequency. Then we will go ahead 3 3 also we can add since its frequency is only 1. Again 4 5 6 we can add all of them into our map, and we can accommodate all of this number. So the another subarray that will form as per the logic will be this. And what is the length of this subarray? So it is 3 plus 3 6. Now what you will say is just take max of both of these 3 and 6, and 6 will be our answer. But no, this is totally wrong. Now let me show you why it is wrong. Let's say 1 2 2 1 3 4 5 and 6. Now actually the biggest subarray that you can form over here is not of length 6, but actually it is of length 7. This is this subarray. This whole subarray starting from index 2 till this end. This whole up subarray is of length 7, and this should be our answer actually. But as per the logic we are getting answer as 6, which is wrong. So it means there is something wrong with our logic. So now we will try to improve it. Again I will be taking that same example, that 2 2 1 3 4 5 and 6. Now what I will try to do is, in the previous logic there was only one pointer, right? But at this time let us use one approach. You can call this approach as a sliding window approach also. So we'll be using two pointers over here. That is, one is the left pointer and one is the right pointer. We will initially keep both the left and right pointers over here, and we will keep on incrementing this left and right pointer until both the pointers are lesser than the size of this array. And once this any of this pointer exceeds the size of this array, then at that point we will just come out the loop and we will just stop our computation. So initially this is the left pointer, this is the right pointer, let's say. So initially both of them are over here only, and in the map currently what I will do, I will keep on, I will try to extend my right pointer as far as I can, because since I want the maximum length, that's why I have to increase the right pointer as far as I can. And once I'm not able to increase my right pointer any further ahead, then what I will do, I will try to increment my left pointer and will try to do something such that again there exists a chance to increase the right one. So how I can do this thing? So first of all, I will look at the right pointer, since I told you that I will try to increase it as far as I can. So whatever element is at the right pointer, is it present in our map? So currently it is not, so we can call that frequency of that particular element is 0 right now. So we can, and our k was 2, okay, so we can definitely add that element into our map. So go ahead, add that element into the map, increase its frequency, and now move the right pointer one step ahead. So put the right pointer over here right now. Look at this element. This element is 2. Is 2 present in our map? No, it is currently not. And we can accommodate at most 2 number of 2's. So definitely we can add it in our map and again increment our right pointer. So our right pointer will be over here now. Now again, is 2 present in our map? Yes, but it is of frequency 1 and I can accommodate one more also. So okay, accommodate it, increase the frequency to 2, and now my right pointer will move ahead over here. Now look, at this point the number is 2. Now if I ask you, can you add this 2 number into our map? You will say no, because already our count is maximum, that is equal to k, or I can say equal to 2. If I try to add this 2 into our subarray, it means I have to increment its frequency in our map also, and its frequency will become 3, that is greater than k, which is not possible as per the condition. So I can't take this 2 right now. It means that my pointer is currently stuck over here. I can't move my pointer ahead from over here, because I can't take this element, and if I can't take this element, then how will I move my right pointer? So obviously now my right pointer is stuck over here. Now as I have told you a while ago, that I will keep on incrementing my right pointer as far as I can. But whenever my right pointer will be stuck, I will try to increment the left pointer in order to decrement the frequency which is already there in the map, in order to unblock the right pointer. If the frequency will decrease, there will become a chance in the future point where I can increase my right pointer. So let me try to create that chance. So in order to unblock this right pointer, so currently my left pointer is at this element, that is 1, and I will be moving my left pointer ahead. And as I will be moving my left pointer ahead, whatever particular element the left pointer was pointing at, its frequency will be decreased by 1 in the map. So currently it is number 1, so its frequency will decrease by 1, that is to 0, and my left pointer will now move ahead. So here will be my left pointer in the next iteration. After moving the left pointer to this place, that is by 1 place ahead, I will again try to check that if my right pointer is now unblocked or not. If it is unblocked, then I can move it ahead. So let us check. So again at right pointer the number is 2 and frequency is 2. So right now I also can't accommodate this 2. So again it will be blocked only in this case. So again I will try to increment my left pointer. The element that the left pointer is indicating, its frequency will be decremented in my map by 1. So the frequency of 2 will now become 1, and this left pointer will now present at this point, at this index. Now I will again check if my right pointer is unblocked or I can move it. So again I will check the frequency of the element that right pointer is pointing at. So it is 2. So the frequency of 2 is now 1 and k is equal to 2. So now I can accommodate one more 2, that is 2 over here. So yes, my right pointer is now unblocked. I can take this element I can increment the frequency of 2 as 2 now, and I can move my right pointer over here. Now again, the frequency of 1 is 0, I can accommodate 2 right now, so I can take this element as well. So I will increment the frequency of 1 to 1, and again I will move my right pointer to over here. So 3 is not there, just simply add 3 with frequency 1. 4, I can also accommodate this element with frequency 1, I can again take it. 5 for 1, and again 6 for 1. So now the length of the subarray will be simply r minus l, wherever is my right pointer minus the position of left pointer. So right pointer will be finally will be at index this, and my left pointer will be over here. So length will be r minus l. This whole condition, I will try to find r minus l, and whatever will be the max among all this length, that is over here we made r minus l as 3, and over here we made r minus l as 7. So whatever is the maximum, I will take it. That is, my answer will be 7 in this case. So I guess this algorithm is clear to you. Now let's look at the code. So here is my code. So first of all, I have made one unordered map, as I have told you, to check the frequency of each and every element. And since they have told us that the nums of I can be in the range till 10 raised to power 9, that's why, just to be on the safer side, I have taken it as long int. After that, I made one variable answer, which will be storing the maximum length possible for a subarray following that condition that they have given to us. And after that, as per the logic, I have made two pointers, that is, one is left pointer, one is right pointer. I can move this pointer until it is lesser than equal to my nums.size. And during each and every iteration, I will first check if whatever element right pointer is pointing at, is it present in my map or not. If it is not present in my map, it means that the frequency is already 0 for the number. So I can easily accommodate it. So I will just accommodate that number. I will move the right pointer one step ahead. I will also increment its frequency by 1 into my map. But if it is not the case, it means that number is already present. It means it is having some kind of frequency, like let's say it is having frequency of 1 or 2, anything. So if that is the case, then I will first check that whatever frequency of that element is that right pointer is pointing at, if it is lesser than k, then and then I can accommodate that number, and I can increment my right pointer to the next one. But if it is not the case, then it means that my right pointer is now blocked. So I have to move my left pointer. For that, I will be decrementing the frequency of element pointed by the left pointer, and I will increment the position of left pointer by 1. And after I increment the position of left pointer by 1, again we will be checking that if my right pointer is now unblocked or not. If it is unblocked, then I will keep on moving the right pointer, and left pointer will remain at its position. Each and every iteration I will be checking the maximum of answer, and right pointer minus left pointer means the length of the subarray that is currently formed, and whatever maximum length that I have previously stored. So I will be comparing that, and whatever is maximum, I will keep on updating it into my variable answer, and finally I will return it. So that was the code. So I hope you guys have understood it. So that was it. Thank you.